Okay. Integral of the absolute value function between 0 and 2 of 2x minus 1 absolute value. I'll come back to this, but I want to show you the graph. If we look at the graph of the absolute value function, of this absolute value function, it looks like that. Okay? So, what's the equation of this part of the line? 2x minus 1. It's 2x minus 1, right? Because that's a positive slope. And if you extended it down, it would have a y-intercept of negative 1. What's the equation of this part of the line? Negative 2x plus 1. So, this part of the line is 2x minus 1. This part of the line, if you remember what an absolute value is, it's defined like this. Absolute value of x is equal to x if x is greater than 0 and negative x if x is less than 0. Okay? So in other words, whatever makes it 0, the x-intercept, is the dividing part. This is the positive part, x, or whatever's in the absolute value, in this case 2x minus 1. But this part is defined as negative 2x minus 1. And then when you put the negative in, you get negative 2x plus 1. That's the equation of that part. Okay? So when you do an absolute value, I'll draw the graph of it. When you're doing this, find the x-intercept, which is going to be what makes it 0 on the inside. In this case, it's 1/2. Okay? You're going to get two parts to the line. You get this part, which is 2x minus 1. But then you get the other part, which is the negative, which becomes negative 2x plus 1. So really, it's two different functions because we're finding the area under the curve between 0 and 1. So this to wherever 1 is, I don't know. Say there. We're finding the blue area, but it's defined on two different functions, okay? So that means we have to split our integral up, which we're allowed to do, okay? Oh, did I say 0 to 2? I did say 0 to 2. So I should make this 2, so it should be bigger. There we go. There we go. Okay, so we're finding the blue area. So this integral then has to be split up into the integral between 0 and 1/2 of the first part, of this part. And that's defined on the curve negative 2x plus 1 dx plus the area, this bit, from 1/2 to 2 of the function 2x minus 1. The hardest part about doing integral, I shouldn't say the hardest part. One of the trickiest parts about doing integrals is the setup. All right, once you get it set up, there's only certain basic rules. We're going to get into more complex ones in a bit. But right now, we only have one rule, which is add 1 to the exponent, divide by the new exponent. Okay, so we just have to set it up properly and then use our rule. So we'll do the first half. What's the antiderivative of negative 2x plus 1? Yeah, it's negative x squared plus x evaluated between 0 and 1/2. And this is where you're going to have to be very careful with your algebra. Plus, what's the antiderivative of 2x minus 1? X squared minus x, right? Evaluated between 1/2 and 2. And now you just have to grind it, okay? So put in the 1/2. So we get negative 1/2 squared plus 1/2 minus, and then you put 0 in. But that's going to turn everything to 0, so I'm just going to put it in like that. Okay? Does everybody understand why it's 0? So I put in the 1/2. It gives me this. And then it's subtracting, and I put the 0 in, but that's all going to just turn into 0. So who cares? So I just write the 0. Plus, now I do this one. Second bit. I'll do it in yellow. Plus, I put the 2 in. 2 squared minus 2 minus, and then you put the 1/2 in. So you just have to keep everything straight. And now you just simplify it. 1/2 squared is a quarter, but it's got a negative in front, so it's negative a quarter. Plus a half, the 0 is gone. 2 squared is 4 minus 2. That's going to be minus a quarter plus a half. Is everybody okay with that? Okay. What's a half and a half? A whole, a 1. So I'm going to get 1. 4 minus 2 is 2. So those are gone. What's negative a quarter minus a quarter? Negative 1/2, right? 2 plus 1 is 3. 3 minus a half is 2 halves, or 5/2. That's the area. Now, you can check it on Desmos. Okay, if you're doing definite integrals, you can check using Desmos. So I'll put this back up in a sec, but if you go to Desmos, we have the graph here. If you go to the front of the graph, go to functions, scroll down on functions, hit the integral sign, then you can put in your bounds. What were our bounds? 0 and 2? The 2, and you have to put dx, and it tells you the answer, 2.5. So if it's a definite integral, you can check. It doesn't show you the graph, but you can check to see if you did it right. Of course, there's all the other ones like Photomath, I think, does it too, and things like that. It just doesn't. I'm sure there's a program that you could find that would show it, but I just care about the integrals. So, okay, is that okay? All right. Let's do another one. This one's mostly just about the wording, what they're saying. So, all right. Find the area bounded by. So find the area bounded by the graph of y is equal to 2x squared minus 3x plus 2, the x-axis, and x equals 0, x equals 2. Wait till you copy that down. Let's do it. Okay. Okay, so here's what the graph is. Here's the graph of 2x squared plus 3, or 2x squared minus 2x plus 2. X equals 0 is the vertical line at the y-axis, this one right here. X equals 2 is this vertical line here, and then bounded also by the x-axis, boom. So the area we're finding is that, okay? Just for the visual. So really, what are we doing? We're going to do the integral from 0 to 2 of that function, okay? You're going to see later on when we have multiple functions, when they cross, you're going to have to set up different integrals depending on what's the top, what's the bottom, and things like that, okay? That's down the road. Right now, we're just setting up the integral from 0 to 2 of our function, the quadratic. So it's going to be integral from 0 to 2 of dx. Can you do this? You want me to just freeze it and we meet at the end? See if we get it right? Okay, go. Please. Not even in the class. How'd it go? Bad. Are we ready? Okay, one more minute.
So for this example, why do we divide 0, 1/2, and 1/2?
Because it's two different lines.
But for this one, we don't really have to.
Nope, because that's only for absolute values. Because you got to break where the lines are different.
Okay.
Right?
So for this one, we just do already. No, this is a different.
10 over 3?
Just, oh my goodness. Oh my goodness. Like,
I think we really
yeah, 10 over 3 for the one.
Bye.
Just got to it. We spoiled the answer.
We feel okay with that?
Not super good.
Okay, so the second, this one here is more about the wording, bounded by this, the x-axis, blah, 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 blah. If you just do a quick diagram or punch into Desmos, you'll see the area you have to do or set up the integral around. So that's more about the wording. If it's an absolute value one, you have to look for where the graph, what do I call it? The vertex of the graph, i.e. It's not always the intercept, but if it's just an absolute value like this, yeah, it's going to be the intercept, essentially. All right, it doesn't have a plus or minus 2 on the outside, but we're not going to worry about that. Okay, so where it breaks, and then one half of it's going to be the positive of this, and then the other line is the negative of that line. Okay, so then you integrate from, well, depending on what your boundaries are, from here to here, and then from here to here, because the functions that you're integrating are different. Okay, so absolute value, that's one thing you have to watch out for. I'm going to give you a couple questions on page 288. 23 and 25. Oh, what? Whoa. There we go, normal. I don't know what happened there, but 23, 25, just one sec. And we'll do 30.
I'm just gonna show it.
35 and 39. Shh, there you go.